So 12.5 is all about adding and subtracting these rational expressions that we have. So think back to fractions. In order to add or subtract fractions, you have to have common denominators. If I give you a problem like 1/6 plus 4/6, that means you have something divided into sixths. And the first one only has 1. And then you have 4 more. 1, 2, 3, 4. For a total of 5 of those same exact pieces. 5/6. So you don't add your denominator, you don't subtract your denominator, you don't multiply them. Once the denominators are the same, all you do is add the numerator, because that's how many pieces of those that you have. So we're going to start off with some easy ones that have the same number in the denominator. So the first problem we can look at, 1a, says n over n plus 2 plus 3n over n plus 2. So since our denominators are the same, we can just add the numerators up. And we have n plus 3n up there. And then always simplify your answer. See what you can combine. So n plus 3n is going to give us 4n's divided by 2n's. And then this can simplify to something nice and pretty. The numbers 4 divided by 2 simplify to 2. And if you have one n on the top and one n in the bottom, they both cross each other off. So that whole big messy thing that we started with simplifies to just 2. Now moving on to the next one, 1b. This one's a little trickier. But because the denominators are the same, just like before, we can add what's in the numerator. 3y squared plus 3y, all divided by y plus 1. So again, we want to see if we can simplify when we get done. So I can't combine anything on the top. You can't add 3y squared and 3y because they're not like terms. But I can factor something out of them. So what do 3y squared and 3y have in common? Well, they both have a 3y that I can pull out. And if I do that, I'm left with y plus 1. And then it's all divided by y plus 1. And then awesome things happen, just like we've been doing before. This stuff crosses off, and all we're left with is 3y. So let's do some more. These ones are very similar. The only thing is when we get done simplifying them, we have to remember that we are subtracting the second fraction from the first fraction. So just like the ones before, notice your denominators are the same. So for 2a, that means that I can just take what's on the top, so 5a plus 2, and I want to subtract the other fraction, 2a minus 4. And then it's all divided by that a squared minus 4. So simplify what's on the top. Remember, this is kind of like a negative 1 right here. So we need to subtract both of these things. So we could rewrite the top without fractions if we have 5a plus 2, then minus 2a plus 4. And then remember, it's still all divided by a squared minus 4. So combine things up at the top. If I do 5a minus 2a, I end up with 3a. And then 2 plus 4 gives me 6. And on the bottom, I still have a squared minus 4. And then we need to simplify. So the top can't be combined. That means my only other option for simplification is to try factoring it. What do 3a plus 6 have in common? They both have a 3. So we take that out. We get a plus 2. And then how can I factor a squared minus 4? That turns into a plus 2 times a minus 2. It's a difference of squares. And hopefully you guys are recognizing those quicker and quicker now. And then we see that some things cross off. On top and bottom we have an a plus 2. So we are left with 3 over a minus 2. So go ahead and pause the video and try to be on your own. Remember that you are subtracting everything in this second fraction here, and then you will definitely have to factor what's on the bottom. So for 2b, you should have simplified the top and then been able to factor it to 4 times b minus 3. And then on the bottom, that trinomial factored to b plus 4 times b minus 1. So nothing crosses off, which is kind of disappointing, but that's all we ended up with. So leave it factored out like that, just in case we need to do something else with it. Box it up, and we're done. So now we're going to get into things that have different denominators. And before we can do that, we need to find something called the LCM. LCM stands for least common multiple. So we're going to use this right now to just come up with numbers. They're not in denominators, but in the next slide, we're going to remember that least common multiples can be the same thing as least common denominator, or lowest common denominator, if it's in a fraction. So least common multiple is just talking about it when it's not in a fraction. But we're going to pretend that these are our denominators, and we need to figure out the lowest common denominator between them. So for the first one, 3a, we have 5f squared h, and then 15f h squared. So we need something that everybody can go into. So let's just look at our numbers, 5 and 15. What's the smallest number that both of them can go into? Well, 15 can't go into 5, but 5 can go into 15. So 15 has to be part of our answer. And then let's look at the f's. We have 2 f's here and only 1 f there. So the lowest common multiple that both of them have is 2. That means for this one right here, I wouldn't have to do anything to make it f squared. But this one right here, all I would have to do is multiply by 1 more f, and I could turn it into f squared. So then do the same thing for the h's. This guy has 1, and this guy has 2. So our lowest common multiple has to be h squared, for the same reason of the f's. And that's all we're going to do for this part right now. So now let's look at 3b. This one's a little more confusing. So the first term that I give you, or the first possible denominator, is x squared minus 4x minus 12. Before we can figure out the multiples of this, we need to factor it. So I want two numbers that add to make negative 4, and those same two numbers have to multiply to make negative 12. So those numbers are negative 6 and positive 2. So x squared minus 4x minus 12 is exactly the same thing as x minus 6 times x plus 2. So this is one term, and this is my other term, x minus 6 times x plus 5. So remember, the least common multiple has to have something that everybody can fit into. So we basically want one of each, one of every part. So since both of these have an x minus 6, that has to be in my least common multiple. This first one has an x plus 2. The other one doesn't, but I could easily make it have an x plus 2 if I multiplied it by that. And then finally the last one, this x plus 5, we have to include him also, because I could easily make the red equation have one by, again, just multiplying it times x plus 5. So this is the lowest common multiple for those two expressions. Kind of messy. But now we're going to use that to do some addition and subtraction of fractions that don't have common denominators. So the LCM of the denominators of fractions, or rational expressions, are also called the lowest common denominator, or least common denominator. You can use the same method to add or subtract rational expressions. So step 1, find your LCD, find the lowest common denominator. Then it says multiply each expression by an appropriate form of 1 so that the term has the LCD in its denominator. Step 3, write each expression using the LCD. And then step 4, 5, and 6 are what we've been doing with the other problems. So before we get into rationals with variables, let's do this with real numbers. If I told you to add 1/7 plus 2/3. Before we can add those up, we need to find the LCD. So you look at your two denominators, 7 and 3. We need to find the lowest common denominator, the smallest number that 7 fits into and 3 fits into. So that number would be 21. So then we're going to rewrite both of these fractions as something divided by 21. So in order to do that, we need step 2. Multiply each expression by an appropriate form of 1. So how can I turn 7 into 21? Well, I'd multiply it by 3. And if I just multiply the bottom by 3, I'm changing the whole thing. So I also have to multiply the top by 3. This is really a big, giant number 1, or an appropriate form of 1. So 1/7 is the same thing as 3/21. And then do the same thing with 3. So to turn this into 21, I'm going to multiply this by 7. Whatever you do to the bottom, you have to do to the top. And this is really multiplying by 1. So we end up with 14/21. And now we're at step 4. Add or subtract the numerator. So 3 plus 14 will give me 17. My denominator stays the same. And then I double check to see if I can simplify. So, can't simplify, I'm done. We're going to do the exact same thing with rationals. So we'll start off easier. For A, I have 4 divided by 3D minus 2D divided by 2D cubed. Yes, some things can be simplified in this beginning problem, but wait until we're done to simplify anything, because sometimes it's a little easier to see. So, take a look at your denominators, 3D and 2D cubed. I need the smallest number that goes into, or that both of those go into. So 3 and 2, the smallest number is 6. And then I need the smallest number of D's that both of them can go into. So this only has 1 D, the other one has 3. So that means the smallest number is 2 to the 3rd power, or cubed. This is my LCD. So now I want to take those fractions that I started with and turn them into something divided by 6D cubed. So go back up to the first fraction. What are we missing? I have 3D, so I need to multiply it by 2 to give me 6, and then I also need D squared. Whatever you do to the bottom, you have to do to the top. So remember, this is just a big, giant number 1, and the fraction turns into 8D squared over 6D cubed. And then the second one, to turn it into 6 on the bottom, I would have to multiply by 3. And I already have the D cubed part, so that's all I need to multiply the top and bottom by is 3. Which again, is a big, giant number 1. So this turns into 6D. And now, because our denominators are the same, we end up with 8D squared minus 6D on the top divided by 6D cubed on the bottom. And now we need to see if we can simplify. So on the top, we can factor out a 2 and a D, and we are left with 4D minus 3. And then on the bottom, we can't really factor anything out, so we're just going to leave it as 6D cubed. And now let's see what we can factor on the top and the bottom. So these two right here can simplify. So I'd get 1 on the top and 3 on the bottom. And then my D's, if I have 1 on the top and 3 on the bottom, 2 of those cross off, or sorry, 1 of those crossed off, and I'm left with 2. So I have D squared in the denominator. And then I can't do anything with that 4D minus 3. So I'm just going to leave it up at the top. And we're done. Since we're running out of time, and 4B is much harder, I want you guys to give that a try. Write down any questions that you have about it, and we can answer them in class tomorrow. Have a good night.